Hello everyone, my name is Mr. Minnick, and today in this video what we'll be looking at is how to solve square root and other radical equations. Now these equations, because it says they're radical, doesn't mean they're gnarly or anything. Well, they might be gnarly, I don't know. But anyway, this can be summarized real quickly. If you notice, you see the Common Core Content Standard says that students will be able to solve simple, they say simple, rational and radical equations in one variable, and also show how extraneous solutions may arise. So that business about extraneous solutions, maybe you've heard of it, maybe you haven't. In my one class, I actually explained that in a really weird way the one time, and I'm not going to go into details about how I did because it's kind of gruesome. So the extraneous solutions, basically, in a nutshell, they're solutions that seem like a part of the problem. They happen mathematically. You do everything right, but what happens is they end up not satisfying the original equation. And here's a trade secret that nobody ever tells you. Really, what happens is you end up with division by zero if you use the solution that seems real but is extraneous. Okay, so hopefully we'll get into one of those, or maybe it's not division by zero. In this context, sometimes it'll be taking a square root of a negative or taking the fourth root of a negative. Okay, so in this instance, it's probably not dividing by a negative, or dividing by zero rather. It's trying to take the square root of a negative. So you'll see those. Also, you'll be rearranging formulas to highlight a quantity. So solving a variable or solving an equation for a particular variable is another skill that you'll see. So if I had to summarize this real quickly, I would say square, again, if necessary, and check. Along the way, I'll show you an alternate way to solve an equation because there's more than one way to solve equations. There's the old-fashioned algebra way, and then you can actually relate it to a function and graph it. And if you use one function, you want the zero. If you use two functions, well, you want their intersection point, the x-coordinate there. So let's get right to it. Problem number one. It says, what's the solution of this? Now, if I had to get the radical out of this problem, at some point I'm going to need to square stuff, okay? Well, the book, normally I don't use the book's advice, but the book actually gives you great advice here. What they say basically here is you isolate the radical on one side of the equation. That is very true, very helpful, great advice. Isolate the radical on one side of the equation, okay? So when they said that one skill that you need is to isolate a variable or a quantity, that's what they're talking about. So if we look at this first problem here, what we need to do is first of all, I call it housekeeping. We need to get this quantity, the radical stuff, we need to get it all by itself. Okay. So to do that, we're just going to do some basic housekeeping. We'll subtract this 3 from both sides. So what we're left with is the square root of 2x minus 3. That quantity now is going to be equal to 5. Okay. So remember I said, in a nutshell, you square again if necessary, and check. So here we go. We're going to go ahead and square now. We're at that point. We're ready to square stuff. The square root of something squared is the something. So we get 2x minus 3 on the left. 5 squared is 25. Some basic algebra gives us that x then equals 14. And if you don't know where that came from, well, I'm not going to fill in the intermediate steps. I'll give you about 8 seconds to think about it and see what I did to solve that linear equation. And so we get 14. Now remember I said check. The big thing you're looking for when you check this is that you're not taking the square root of a negative, because it's impossible to take the square root of a negative. So if we go back to the original problem, this yellow might not show up so well, but 3 plus the square root of 2 times 14 minus 3. Is that really equal to 8? That's what we want to know. That's 3 plus the square root of 28 minus 3 is 25. Is that really equal to 8? So we have 3 plus 5 Is that equal to 8? Sure it is. Okay, so 14 is our solution to this particular problem. Okay, now I did mention that I would show you a couple different ways to solve this. So going to the TI Inspire now, what I'm going to do is solve this using one function and then using two functions also. So as one function, what I would have is 3 plus the quantity. So I'm going to go document. Every time I try this, my smartboard and I don't get along, but that's okay. I'll figure it out. So I'm going to go document. I'm going to insert a graph. So I'm going to graph the function 3 plus the square root, and I think I had 2x minus 3 in there. I said 2x minus 3 in there. The 2 didn't show up here. And then on the other side of the equation, if I'm not mistaken, wasn't it? It was equal to 8. Let me just double check. Yeah, that was equal to 8. So what I'm going to do then is bring the 8 over, so it'll be minus 8. Okay. And when I graph this in one function, what I'm looking for is the 0 of the function. In other words, where does the graph cross the x-axis? So I'm going to go menu. I'm going to use analyze, and I'm going to trace. Nope. I'm going to trace and graph trace, and I'm just going to walk along this graph until I find a 0. Until I find a 0. And it might take a while. And for some reason, the way the window's showing up is kind of weird, but there it is. It says there's a 0, and it's not showing up the greatest, but it's actually at 14, 0. So there's that. If I did this in two different functions, rather than graphing what I graphed from the onset, I would graph the one function, 3 plus the square root of 2x minus 3. I'd graph that. And then the second function that I would graph would just be 8. And what I'm looking for here is the x-coordinate where these things meet. Now, I'm not going to see it, so I'm going to go menu, window, and I'm going to go zoom fit. And I can now see where they intersect, so I'm going to go menu, analyze, calculate the intersection. And the x-coordinate where they meet is 14. So to be honest, algebraically, it's so much faster. How hard was it to do some housekeeping and square some stuff and do all that? So, but as we go on, we'll see where it's handy to know these other ways of solving. Okay, because sometimes we're going to get two answers that we think are answers, when in fact only one of them is the answer. Sometimes there are going to be two actual answers. Okay. All right. So we've seen the basics of this. So let's try this got it problem. So in this got it problem, we've got the square root of 4x plus 1 minus 5 equals 0. So we're going to do some housekeeping. 4x plus 1 equals 5 under square root the 4x plus 1. A lot of people will skip steps, and I almost did along the way here. I square this and I square this. So this is 4x plus 1, and that equals 25. So then I get x equals 6. And if I plug 6 in, 4 times 6 is 24. 24 plus 1 is 25. The square root of 25 is 5. 5 minus 5 is 0, and it's all good. So 6 is the one unique solution to that. Again, if you don't know where I got 6 from that linear equation, at this point in time, I'm not going to show all those intermediate steps. You should be able to solve that linear equation pretty handily. So problem 2 now. Ooh. They've got some weird exponents going on here. In this problem, we've got 3 times the quantity x plus 1 to the exponent 2/3. And that's equal to 12. So again, we're going to do some housekeeping. And if you remember anything at all about fraction exponents, all they really are is radicals. So I'm going to divide by 3 before I do anything else. So that's going to leave me with x plus 1, the quantity, to the 2/3 power. That's going to equal 4. Okay, all I did was a little bit of housekeeping. So now, if I want to get the quantity x plus 1 to the first power, what I need to do is exponentiate this. In other words, raise it to a power. And the power that I need to raise it to needs to make that power 1. So a power of a power is a product of the powers. So what I want to do is I want to raise this to the 3/2 power. In other words, the reciprocal because that's going to give me x plus 1, the quantity to the 2/3, times 3/2. And that, of course, is going to end up becoming x plus 1, the quantity to the first power, which is just going to be x plus 1. Okay, so I can even get rid of these parentheses. The red one, don't ask me where it showed up from. Okay, so don't forget what you do to one side, you do to the other side. So we're going to exponentiate the other side to the 3/2 power. Now remember, when you do that, it's like, well, you might want to write this down off to the margin somewhere. Remember, x to the a over b power, it's the bth root. It's the bth root of x to the a. So 4 to the 3/2 power is really the square root of 4 cubed. Okay? It's the square root of 4 cubed. Now, if you go reaching for a calculator to evaluate this, shame on you. We're going to get x plus 1 on the left. 4 cubed is 64. 64 square root's 8. Okay? And you might think, well, it's plus or minus. Maybe it is. Maybe it isn't. Maybe it is. Maybe it isn't. So then we're going to have x equals -1 plus or minus 8. So that tells us our two possible answers are x equals -9, because that's -1 minus 8. The other answer, we think, might be -1 plus 8, which would be 7. So we think that those are our two answers. -9 and 7. Well, let's go back to the beginning. Let's go back to the beginning and plug in each one and see if each one satisfies what we started with. 3 times -9 plus 1, the quantity to the 2/3. Is that equal to 12? That's 3 times -8, the quantity to the 2/3. Is that equal to 12? So I could divide by 3. So that's -8 to the 2/3. Is that equal to 4? Remember, when you raise something to the 2/3 power, it would be like taking the third root of it and then squaring it. Well, what's the third root of -8? Well, it's -2. And -2 squared is 4. Hey! The -9 actually worked. Interesting. Interesting. Well, let's try the other one. Let's try the other solution. 3 times 7 plus 1 to the 2/3. Is that equal to 12? So that's 3 times 8 to the 2/3. Is that equal to 12? So we get 8 to the 2/3. Is that equal to 12? Is that equal to 4 now? I divided by 3. So the third root of 8 squared, is that equal to 4? That's 2 squared. Yeah, hey, that one works too. Now remember, I said sometimes being able to solve these using another technique is handy. Okay. I don't know if I have my TI, my virtual TI on here. Maybe I don't. Okay. So let me go back to my graph here then. I'm going to try to get my viewing window. Oh, it's zoomed at 150%. Maybe that's what's going on here. So let me try zooming to 100%. There we go. That should solve that problem. So I'm going to go doc. I'm going to insert a new problem in a graph page. So I think I had 3 times the group. I said times the group. 3 times the group of x plus 1 to the 2/3. X plus 1, that quantity, to the fractional power of 2/3. And all that equaled 12. So what I'm going to do is I'm going to say minus 12. And that way I'm just going to do this as one function, and I'm looking for the 0 or zeros. And if I look at this function, hey, wait a minute. The graph goes through when x is 7. The graph goes through when x is 7. Let me try the... Well, let me just go to the table. Control T. Because when x is -9, Looks like I get an imaginary solution. Maybe the TI-89 or the TI Inspire is going to let me down here. Maybe the TI Inspire is going to let me down here. We all love the TI Inspire. However, I have a hunch that the TI Inspire lets me down on this problem. Let me get my TI-83 going. Might not be very often that it happens, but it does from time to time. So on my TI-83, if I go to graph, let's see, it was 3 times the quantity, x plus 1, the quantity to the 2/3 power. I got to be real careful how I enter that power here. And then minus 12, and then I'm going to graph that. Whoa! I go second trace. I want to calculate a 0, choosing a left bound of -10 and a right bound of 0. -9 is a 0, but the TI Inspire says, you know what? It's not. Well, I've got news for you. The TI Inspire let us down. We did algebra. We did algebra right. We checked our work, and it checked out. The TI Inspire in this particular problem let us down. It failed us. Bad TI Inspire. The TI-83, it's old school. It's been around since 99, and it actually showed us the right answer. As far as why the TI Inspire failed on that, I don't have the answer to that just yet, but I am going to look into it, and I'll let you know. So the point is, when you do these, you should trust your algebra skills. Use the calculator sometimes as a tool to check to see if your algebra skills confirm that, but unfortunately the Inspire kind of lets us down on this one. Let's try another one. This one I've got some housekeeping to do. I have 3 times the 5th root of x plus 1, the quantity cubed. Be real careful how you write these. When you're writing these on pencil paper, make sure your index is in fact an index, because it's easy to confuse an index with a coefficient. Okay. So after a little bit of housekeeping, what I'm going to have is the 5th root of x plus 1, the quantity cubed, is going to equal 8 after some housekeeping. Okay. Hopefully everybody's with me so far up to that point. So I want to get rid of the 5th root. So I need to exponentiate. So I'm going to raise both sides to the 5th power. A quantity to the 5th power, if it's under the 5th root, that's going to cancel out that stuff. So I'm going to be left with x plus 1, the quantity cubed. That's going to equal 8 to the 5th. Okay. Now I know what you're thinking. You're thinking, well, hey, wait a minute. Couldn't we have done that a little different? Couldn't we have written x plus 1 to the 3/5 power? Yeah, you could have. You could have. But to continue on with this one, what I need to do now, I'll kind of do that side by side here in a second. So what I need to do now is go ahead and raise this to the 1/3 power, or take the 3rd root of it. Okay. Remember, taking the 3rd root, raising it to the 1 power, same thing. So I want to raise this to the 1/3 power. Okay. So that's going to give me x plus 1 equals 8 to the 5/3. All right. So then 8 to the 5/3 is really the 3rd root of 8 to the 5th. So that's x plus 1 is the 3rd root of 8 to the 5th. 3rd root of 8 is 2. 2 to the 5th is 32. So here I'm going to get 31 for my solution. Okay. Lots of different ways we could have done this one. From the onset of this problem, I could have rewritten this as x plus 1 to the 3/5 power equals 8. And then I would have exponentiated both sides to the 3/5 power. I'm sorry, to the 5/3 power, to the 5/3 power, to the 5/3 power. So that probably would have got me there a whole lot faster. Whole lot faster. So there's more than one way to the Eastwood Mall. This one has one solution. If we check it, 31 plus 1 is 32. 32 cubed. Well, I don't want to cube 32 just yet. So I'm going to hold off on that. I'm going to take 32's fifth root, which is 2, and 2 cubed is 8, and 8 times 3 is 24, and 24 plus 1 is 25. This one checks out. So you say, well, let's graph it. Let's make sure it's 24. Let's graph it, because now we know how to do this. So here we go. So y equals 3 times 5 math the xth root. I have to put the index in first. Under the root, I got x plus 1, the quantity math cubed. Just to be safe, I better put another parenthesis in there, indicating that I want the root of all that quantity cubed. So close that, and then plus 1, and then minus 25. And I'll graph this. And I'm looking for the 0. Let me try zoom fit. Zoom 0, zoom fit. The calculator's really working hard on this one. So there's my function. If I trace it, it's going to take a while to get to that 0. It's going to take a while to get there. I'll bet it's when x is 24. Let me just calculate a value when x is 24. It's going to tell me, no, let me just go to the table. Second graph. Let's go right to the table. Second graph. I said second graph. I said second graph. Second graph. 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 Okay, 3 weeks later, we made it to the table. And the 0 of this function, indicating that that is also the solution. Or, no, it wasn't 24. We said it was 31, right? Sorry about that. There we go, 31. We have a winner. Okay. So this one says, what are the solutions to this? Well, let's see what happens. Let's see what happens. We've got 2 times x plus 3, quantity to the 2/3 is 8. Some housekeeping says x plus 3, the quantity to the 2/3 is 4. I'm going to exponentiate both sides to the 3/2 power. So then I get x plus 3 on the left. On the right, I get 8, and so I get 5 for the solution. 5 plus 3 is 8. 8's third root is 2. 2 squared is 4. 2 times 4 is 8. That one checks out, and that's that one. Okay? So we haven't seen any difficult ones yet. These are the simple ones. Ooh. Ha. Ha. I knew they'd get more difficult eventually, so here we go. The square root of x plus 7 equals x plus 5. Square again if necessary, check your work. I'm going to surprise some people here. On the left is no surprise. On the right is going to surprise some people, and they're going to say, where'd that come from? Well, I'm not going to tell you. So there's what we've got going on with that. Okay. So, once we get it that far, looks like I've got a quadratic equation. Oh, this one factors. What am I thinking? This factors. Wow. Wow. Yeah. Yes. 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 So I think that x is negative 3, and I think that x is negative 6. Okay, I think. But I got to check. Negative 3 plus 7 is 4. 4 square root is 2. 2 minus 5 is negative 3, and negative 3 is negative 3. Hey, the negative 3 checks out. Negative 6 plus 7 is 1, and 1's square root is 1, and 1 minus 5 is negative 4, but negative 4 is not negative 6. So the negative 6 doesn't check out. But it worked. We did everything right. If we solve that quadratic, x squared plus 9x plus 18, then we get negative 3 and negative 6. Yeah, that's true, but the problem is that was synthetically created through some algebra, and that's not what we started with. If we solve x squared plus 9x plus 18, and let's go to a standard window, the solutions of that are negative 3 and negative 6, okay? The problem is what we did to do that is we squared a square root, and when you square a square root, some weird stuff happens, okay? So we get x plus 7 under this root, close that, minus 5, and then minus the x, okay? So I'm graphing this, and I'm looking for the 2 zeros. Well, there's not 2 zeros. Watch what happens. If I calculate a value when x is negative 6, the original function doesn't equal 0 like it should. So extraneous solutions that look like solutions, algebraically you did everything right, but they don't satisfy the original equation. Okay, so the point here is in this one, negative 6 is what we say it's extraneous. So it's not a solution. So the only solution to this is x equals negative 3. Okay, so that's that one. Let's try another one. 4a, we've got square root 5x minus 1 plus 3 equals x. So we've got 5x minus 1 under root equals x minus 3. So now I'm going to square and square. So I get 5x minus 1 is x squared minus 6x plus 9. So I get 0 equals x squared minus 11x. Wow, they're being nice, plus 10. So 0 equals the quantity of x minus 1 times the quantity x minus 10. So I think my answers are x is 1 and x is 10. That's what I think my answers are. So let's check. 5 times 1 is 5. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. But 5 doesn't equal 1. So what's that mean? Well, it means that over here is my extraneous solution. 5 times 10 is 50. 50 minus 1 is 49. 49 square root is 7. 7 plus 3 is 10. 10 equals 10. So 10's the solution. How do you tell which one it is? You have to check. How do you tell which one's the extraneous? Sometimes it's a bigger one. Sometimes forget the bigger one. Forget the smaller one. You just have to check. But there's got to be, maybe there is. I don't know how to tell with a shortcut, so you got to check. Got to plug them in. It's that simple. Okay? When should you check for extraneous solutions? You should check for extraneous solutions anytime you square a square root with a binomial being squared. Okay? With the binomial being squared. If you look back at the earlier examples where we didn't have extraneous solutions, we weren't squaring binomials. We weren't exponentiating binomials. We were exponentiating numbers. Okay? Anytime you exponentiate a binomial, something with some x's and stuff in it, that's where this weird stuff happens. Okay? So, let's try one where you have to square twice. Oh, no! These ones, I'll be honest with you, these ones can give you fits. Square root 2x plus 1, and this is why we did the homework that we did earlier this week. Minus rad x equals 1. So again, I'm going to do some housekeeping. I have rad 2x plus 1 equals 1 plus rad x. And now I'm going to square. Okay. Now, since we just looked at this earlier this week, I will show some of the intermediate steps here. On the left, of course, we get 2x plus 1. On the right, we get 1 plus rad x times 1 plus rad x. So on the left, we have 2x plus 1. When we FOIL, we're going to get 1 plus rad x plus rad x plus rad x rad x. On the left, we still have 2x plus 1. We get 1 plus 2 rad x plus rad xx, which is going to be rad x squared, which is just going to be x. Okay? Hopefully you're with me up to that point. Now, it's easy to square something when the radical's by itself. Remember earlier they said isolate the stuff with the radical in it. Okay? So what I'm going to do is I'm going to bring this x over here, and when I do that, I'm going to have 2x minus x, which is going to give me x. Hey! Then I'm going to bring this 1 over here with this 1. 1 minus 1 is 0, so that's cool. So I'm going to have x equals 2 rad x. Okay? Now I'm going to go ahead and square both sides. I got to be real careful here when I square this. Make sure you remember your exponentiating rules. So I'm going to square this, and I'm going to square this. I get x squared on the left. On the right, I get 2 squared times rad x squared is going to be x. Okay? So I get x squared equals 4x, or x squared minus 4x equals 0. So I get x times x minus 4 equals 0. So I think my answers are 0 and 4. That's what I think. Wow, that took a lot of work. You're darn right it did. So we think our solutions are 0 and 4. Wait, can you scroll back up? Yes, I can. So we got the single radical by itself. We put the other expression with the 1 plus the radical. We squared, and on the left we got some stuff. On the right, we did what we did a couple days ago in class. And then we just end up with a basic quadratic that factored quite nicely. So we think 0 and 4 are our solutions. We think 0 and 4 are our solutions. 2 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. 1 minus the square root of 0. Square root of 0 is 0. 1 minus 0 is 0. I'm sorry, 1 minus 0 is 1, and 1 equals 1. So the 0 is a solution. If we check the other one, 2 times 4 is 8. 8 plus 1 is 9. 9 square root is 3. Square root of 4 is 2. 3 minus 2 is 1. So they both check out, it seems. Maybe we should double check this with the graph. Because the directions say what is the solution. It doesn't say what are the solutions. So maybe we better check this with the graph. Square root, under root, we got 2x plus 1. And then minus a rad x. Close that. And then minus a 1. Let's graph this and see what happens. Ooh. Ew. Let me try a zoom box because this graph is pretty intriguing. Can't quite tell what's going on here. Let's zoom in a little bit on this region and see what happened. Okay, it looks like 4 is a solution. Calculate a value when x is 4. Y is 0, so 4 is definitely a solution. Let's calculate a value when x is 0. We got both of them as solutions. They both work. So what is the solution? Well, got news for you. The book's authors, they got a typo. 0 and 4 are both solutions here. They both work. Algebra doesn't lie. We could do one more. I think we got time for it. Yeah, last one. Here we go. Last one. Rad. Get my purple marker going here. Rad 5x plus 4 minus rad x equals 4. So rad 5x plus 4 equals 4 plus rad x. So I will skip a few steps here. So we square that. When we square that, we get 5x plus 4. We're going to get 16 plus 8 rad x plus x. So then we're going to get 4x minus 12 equals 8 rad x. Oh, this one gets interesting, doesn't it? Because now when I square, I'm squaring this. So I get 16x squared minus 96x plus 144 equals 64x. So I get 16x squared minus, I think that's going to be 160x plus 144 equals 0. Have a feeling that tonight's going to be a good night. Tonight's going to be a good night. 144, is that divisible by 16? I said, is that divisible by 16? I said, is 144 divisible by 16? 9, okay. So I could factor a 16 out of this. So this is 16 times x squared minus 10x plus 9 equals 0. So I get 1 and 9 as my would-be solutions. I think 1 and 9 work. I think 1 and 9 work. If I plug in a 1, 5 times 1 is 5. 5 plus 4 is 9. 9 square root is 3. 3 minus 1. Oh, the 1 doesn't work. If I plug in 9, I get 45. I get 49. That's 7. 7 minus 3 is 4. The 9 works. How can you tell? Well, either you cheat and use a calculator to graph it, or you just do the math. You do the algebra. By the way, the class is called algebra for a reason. So, anyways, when we do this, we check this out, we close that, we bring the minus 4 over, and we graph it. And we do a standard window zoom 6. And we thought that 1 might work. 1's not a 0. But if you calculate a value when x is, I said if you calculate a value when x is 9, 9 is a 0. So there you go. That's it. That's how it goes. This has been solving radical equations. It has been pretty radical. Have fun with it. If you have any questions, don't hesitate to ask. See ya.
Go.